So let's talk about the isosceles triangle. Okay, remember I gave you a definition of the isosceles triangle a long time ago, which was last week. Seems like a long time ago. You may remember what it was. Juliana, what do you think? I saw your hand first. What do you think? Yeah, it's a triangle in which two or more sides are congruent. We're going to stick with this one for right now. We're going to specifically talk about for us, right? It is a triangle with at least two congruent sides. But in this particular case, we're gonna actually focus on a triangle that has exactly two congruent sides. Because if it has more than that, all three, then we're talking about an equilateral triangle. And so I want to focus this lesson primarily on isosceles with exactly two. So what I mean by that is here's the picture that we're going to have. All right. So this is going to be an isosceles triangle because these two sides are going to be congruent. That's what we mean by isosceles. That's the picture. The little tick marks indicate that those sides are congruent. We call each of those sides a leg. That's a leg, and that's a leg. So if those two sides are called legs, then the third side has to be called something else, and we call that the base. All right, good try. I like it. We call that the base. Okay, when it's not the same length as one of the legs, we just call that a base, which is why I'm sticking to this lesson, having only two sides be congruent. Does that make sense, you guys, so far? Okay, it does not necessarily have to be at the bottom either. I could have this picture as well. I could have that, and where would the base be? The base would be up here. So base doesn't necessarily have to mean bottom. It just means the other leg that's not congruent to the other one in this particular case for the isosceles triangle. Does that sound good to you so far? Okay, so given, same box here, go back up to there. Is that what you need? Yep. So given this picture, if this is going to be a leg, and this is going to be a leg, and this is going to be a base, all right, then we have some other information here. This angle down here and this angle down here, these are going to be called something. These are going to be called your base angles. Oh, doesn't that make sense? Those are going to be called the base angles because they are next to what? The base. They are next to the base. Absolutely. They're called the base angles because they are next to the base. There is another angle in this picture. See it? Since it is a triangle after all. I like where your head's at. The leg angle? No, we're going to call that the vertex. The vertex angle. So the reason we give these things names is that we can talk about them. If I tell you an isosceles triangle, right, you can find the base angles. As long as we're talking about an isosceles triangle that has exactly two sides equal, not the third, right? We're talking about the first case of isosceles triangle, not all three equal. Then we can also talk about the vertex angle so we know what we're talking about. So there's one vertex angle, two base angles, two legs, and a base. So, fair enough? All right, I'm going to go up here. Same box here. I'm going to keep drawing some more pictures for you. All right. When you have an isosceles triangle, such as this one here and such as this one here, isosceles triangles are symmetric with themselves. So what do I mean by that? They're symmetric with themselves. Yeah, what do you think?
Fold them in half.
Yeah, it's exactly right. You can actually fold them in half and they make a mirror image with themselves. So that means that they make a right angle straight down the middle. That's called an altitude. Drop straight from the vertex angle down to the middle. They are symmetric with themselves. So no matter how you draw them, isosceles triangles, okay, if that piece and that piece, then they will be symmetric with themselves and you can draw a straight line down the middle. And they make a right angle that's always perpendicular to the base. See how this angle is perpendicular to the base? Here's my leg, here is my leg, and here is my base. And they always make a right angle perpendicular to the base. Yeah, I'll meet. Okay, so the isosceles triangle theorem says this. It's given to you in two parts, and one's just the converse of the other. What's converse mean again? You just switch it around. You just switch them, right? Okay, so the first one says this. If two sides of a triangle are congruent. Okay, if two sides of a triangle are congruent, then the two opposite opposite angles are guaranteed to be congruent. So what do I mean by that? Let's take a look at a picture. Here's what I mean. If this side and that side, this is the if statement. If two sides of that triangle are congruent, the isosceles triangle theorem then will tell us that the two opposite angles, this angle and that angle, must also be what, you guys? Congruent. Okay, so if those two sides are congruent, then the two opposite angles are congruent. Okay, now, what's the converse of this statement, everybody? And that's the second part of the isosceles triangle theorem. It says if two angles of a triangle are congruent, then what? The sides opposite those angles are congruent. So the picture for this one would just be the drawing that we had, except the arrows would be going in the other direction. So if I know this, if I know that and that, right? If I know that those two angles are congruent, what can I then say about the opposite sides? Then that means that this side and that side must be congruent. Okay, here's a picture I have for you. Take a look at it. First of all, ladies and gentlemen, is this an isosceles triangle, yes or no? How do you know it's an isosceles triangle? Because at least two sides are congruent. Good. What else do you know? What's the vertex angle? 30 degrees. Okay, so if the vertex angle is 30 degrees, how much is left over in the entire triangle total? 150. Okay, so there's 180 degrees total, right? How much do we already have used? We already have 30 degrees used. So that means we have how much left over? We have 150 degrees left over. Now, if this is an isosceles triangle, well, how do you know? You know something about these two angles. What do they have to be? They have to be the same, right? That have to be the same. So if I take 150 and divide by 2, what do I get? Whoa. I get 75 degrees, right? 150 divided by 2 is 75. Therefore, x has to be 75 degrees. Okay, next example here. This is a triangle. The sides are labeled y plus 5 on the left, 2y minus 4 on the right, and then a 3y minus 12 down below. Well, here's my question to you. I want you to solve for y. What can we infer from this already? Anybody? Say something about it. Yeah.
All of those equals 180.
All the interior angles sum up to 180, true, but how does that help us solve for y? Juliana, what do you think? Yeah, exactly. So these two angles are congruent. Is that true? Hold on. Well, you do know that because the isosceles triangle theorem. Are those two angles congruent?
Yes.
If those two angles are congruent, what must that side and that side be?
Congruent.
They must be equal to each other. That's what congruent means. So we must be able to say y plus 5 is equal to 2y minus 4. That's what we can say. Yeah. Yeah, you were given that the angles at the bottom were congruent. Sorry if you didn't know that. Yeah, you were given the angles at the bottom were congruent, the base angles. You were given that. So therefore you can make using the isosceles triangle theorem, you can say then that y plus 5 is 2y minus 4. And then let's do some algebra here, you guys. So what do I do?
Y equals 9.
Oh, wow, okay. You guys are just on top of it. Y equals 9, yeah, awesome. Okay, here's a picture. Here's a triangle. I've given you one angle is 56 degrees. Another angle is 62 degrees. The other angle is not labeled. And I want you to solve for z. Okay. Okay. Yeah, exactly, right? Alright, so 180 total. We're going to subtract off 56. We're going to subtract off 62. What does that leave us with? That leaves us with 62. So that means that this angle is 62. Oh, hey, check that out. That means that this angle and that angle is the same. So what does that tell you? Exactly. That this side and that side must be the same. Therefore, z must be 42.